So go ahead and pause the recording if you haven't read through the word problem yet. I'll jump right to the question parts. First question asks us to compute the average value. So sometimes an average could mean like a slope between 2 points. That would be, if we were to calculate a slope though, that's an estimate of, you can think of it as an estimate of a derivative. We don't want to go further down in like that derivative chain. We're on acceleration. The rate of change of the acceleration is jerk, and that's not what they're looking for here, right? So what we can do is we can use something that's usually defined in a first semester calculus course. We can use the formula for the average value of a continuous function. Oops, sorry, this is supposed to be A to B. You take the, it's first the length of the interval, so B minus A. You write that as its reciprocal, and then so it's like you're dividing by the length of the interval. So it depends on what type of letters they use, but this is the average value formula. We want the average value of the acceleration between 5 and 0. So we're integrating from 0 to 5 of this function. Okay, so if you compute that integral, and then if you divide it by 5, or in other words, multiply by 1 over 5, then you've computed the average value. The second part is asking us to find the corresponding velocity equation. So if this is acceleration, then velocity is just the antiderivative of acceleration. So what you want to compute is the indefinite integral with respect to time here, so dt. So compute this, and then the final velocity is 70 miles per hour. So that would be if, final in terms of, that must mean 5 seconds. So to finish out, when you do this antiderivative, to finish it out, you're going to have plus some constant c, right? To find out what that constant c is, the final time period is at time t equals 5, and the velocity should be 70. So evaluate this antiderivative, and then you'll have velocity. You want to plug in 70 in for the velocity, and then you want to plug in 5 in for t. And then you can solve for that constant c, okay? This part says using the velocity equation, find the corresponding, oops, actually, sorry, I skipped over something. Part C here. Asks you to find the velocity at time t equals 0. So since in part B you found the velocity equation, you just have to plug in 0 for t and evaluate, okay? Using the velocity equation, find the corresponding distance equation. So that would just be the antiderivative of velocity with respect to time. And then again, they give you initial distance is 0 miles. So what you'll want to do is you'll have a distance equation, bunch of algebra, then plus some arbitrary constant c. That initial information gives us that constant c. We just have to plug in some information to find out what it is. The initial distance, so at time t equals 0, you should be plugging in 0 in for distance. And then here in your algebra, you should be plugging in 0 in for time. And then you can solve for that constant c. This last question says, how far did the driver travel while the car accelerated? So the accelerating period ends at time t equals 5. So what you want to do is plug in 5 in for the distance, but the units are going to be a little bit different. We have to do something extra here, okay? Because if we go back, this is miles per hour per second. So think about the units of acceleration. The units of acceleration, they said, was miles per hour per second, okay? Velocity was the antiderivative of acceleration with respect to seconds, with respect to time. So it became miles per hour. And then distance, here's another way to write miles per hour. That's miles per hour. Or if we want to put it back in terms of seconds, that's miles per 3,600 seconds, right? So to find the distance, when we integrate, we lose, it's integrating with respect to time in seconds, but we haven't lost that 3,600. This is miles per divided by 3,600. So whatever you get here, if you plug in 5, you're going to have to plug in 3,600. Sorry, one extra little bit here. Remember, when you do this, that's going to be your answer in miles. You got to convert it to feet. So you just got to multiply by, 5,280 feet per mile. So whatever you get from this computation, just multiply by 5,280 feet to turn it into feet.